My name is Diogo Gomes. I'm the coordinator of Project 5GASP. I'm a researcher at the Instituto de Telecomunicações and a professor at the University of Aveiro, Portugal. And I would like now to present you the main results and contributions of Project 5GASP. First off, you probably know about 5GASP, but yet I got a slide just to remind everyone of our main objectives. When we set forward the proposal, our objective was to accelerate SMEs towards the new 5G world. And this 5G world, we tried to address it from the software point of view. So we addressed network applications and network application developers, especially, that wanted to develop applications for 5G. Nowadays, we are on to the 6G. We are starting our projects on 6G. We are doing new developments, but many of the things that we did in 5GASP can also be applied to 6G. So it is important to bring all this knowledge into the new project. 5GASP offers and operates an open and interdomain 5G NFV-based reference ecosystem of 5G experimental facilities. I will show you all the facilities we have, but this was an important thing that we brought in. We created the tools and the mechanisms to easily set up test beds across Europe, but also the means to federate all these test beds and to promote experiments across all these test beds through a 5G NFV-based network fabric. 5GASP platform provides facilities to test and validate network applications. So our main concept was to develop CI/CD processes for network applications. This is very common in software, but not so much common in networks and telecommunications. So we had to do lots of stuff and lots of new developments to extend these concepts into the telecom world. We embraced a fully automated DevOps-based CI/CD process for developers, which can translate the application services into network applications. And it takes into consideration the vertical specific requirements of special areas. 5GASP focused itself on two verticals, automotive and PPDR, and we tried to address their specific needs throughout the project. But we are not limited to just these two verticals. Most of the platform and the process that we develop, but also the tests that we develop and publish, and we will talk about this later, have been made in a way that can be used by other verticals. So this is something that we want to communicate. We created a process by which we do a virtuosos circle, in which we start by the definition of what we want to do. So the idea behind our applications, we create the software taking into consideration the 5G specificities, how they can integrate with the network through the northbound interfaces, and that we'll talk about later on also. And we test how these applications interact with the network. We test how they perform on the network and how the developers can iterate this process, continuously improving their network applications. So one of the first contributions that we made in 5GASP was actually a contribution at the architectural level. 5GASP was involved in the 5G PPP work groups, especially on the software work group. And there we were able to contribute through our partner, University of Patras, to a very important white paper with the definition of what is a network application. This was very important because from the outset of the project, there was not a clear understanding by all the companies, not just inside the project, but across the 5G PPP, of what is a network application. So it was important to define what was a network application. And we got to this definition that I show you here, extracted directly from the 5G PPP architecture white paper, that a network application is a software piece that interacts with the control plane of a mobile network by consuming exposed APIs in a standardized and trusted way to compose services for the vertical industries. And we focused ourselves on two main APIs, the 5G APIs provided by the northbound namely the NEF API, and this is why it was important and is important for us to present to you in two presentations from this one, how the NEF emulator is very important to validate the use of this interface. But we also explored, for instance, the CAPIF interface and the CAPIF APIs. So we focused on these two interfaces to capitalize on the network application communication with the core network and how they interact with 5G technologies. This is our gateways to 5G. And it is important for us that network application developers, which are software developers in that, they understand and they can work out using their own tools with these interfaces in a very simple manner. This is very important for 5G to achieve its goals, but not just 5G. Also 6G will be very much limited by the amount of applications that can be developed to take advantage of the new technology. It should not be just about the radio stuff. We are all here in this room, I expect, software engineers. So we expect to have clear APIs and interfaces that we can use to exploit all these physical capabilities that these new mobile technologies bring us. Another important aspect that we worked out in the scope of architectural discussion was the 5GAS triplet. When we discuss cloud computing, we usually focus ourselves in the description of our application service. Okay, it can be our container descriptor or our Ansible scripts, whatever that helps us deploy our applications into an infrastructure. But for 5G, it's more than that. It's also the aspect related to the network deployment, the network orchestration. But we did not create a tuple, we created a triplet. Why did we create a triplet? Because in 5GAS, we focused on the continuous integration and continuous deployment aspect that involves testing. So we extended the concept of describing the service from the application side, the service from the network side, to also include the testing aspects. So we created the concept of the 5GAS triplet, which integrates the network application NFV artifact, which basically describes the application, how it's deployed on the NFV infrastructure. We include the NES, which is the network slice template as defined by BridgeP. And we included yet another aspect, which is the test descriptor, which describes the tests that should be performed post the deployment of the network slice and the network application in a network. So to validate that all the things that we asked for through these previous descriptors can actually be deployed and validated on the network. So the network application NFV artifact realizes the network application to be deployed. The network slice that needs to be activated and configured prior to the deployment of the network application, and the test suite, which describes in terms of a test descriptor model, what will be executed after the activation of the application. This concept is very keen to us, 5GAS, because it is the core of our 5GAS process. All things that happen through the 5GAS process depend on the proper association of this triplet. Each of the steps will consume the information coming from the triplet, and at the end, the process, we will only have an application certified and fully tested according to the test script that has been provided. To make these things happen, we resorted to an important piece of software, which in 5GAS we call the NODS, or Network Applications Onboarding and Deployment Service. And 5GAS NODS is based on an open source tool called OpenSlice. OpenSlice has grown a lot in the past years. It has reached an important state nowadays, has become an SDG part of ETSI, so it is being promoted inside ETSI. It will definitely outlive 5GAS. And we will have a presentation right after my talk about OpenSlice and what has been done in OpenSlice and how it will progress into the future. But we believe that OpenSlice is one of the main results of our project. It's how we see the the work that we developed during the project outliving the project itself. We created the cross-domain network orchestration platform. This was also very keen to us because when we set out as an objective in FiveCast to create an inter-domain testbed, when we said that we wanted to create a cross-domain orchestration mechanism, we did not have very clear idea how we were going to achieve. But from the beginning, we decided that one of the best ways to achieve it would be to use our own tools and concepts. So what we ended up doing was to create an overlay network using NFV concepts, creating a network application itself to orchestrate our interdomain fabric. So we created a network application that we named NetOr, short for Network Orchestrator, that is basically a tool that can create tunnels across all our sites, creating an NFV overlay, slice, you may call it, where network applications can be deployed across all the test beds. This tool can be extended to any given use case application. It's not limited to our project. It's quite standard. It's based on open source tools such as WireGuard, and it has been validated and tested through our process. So we can actually deploy our interdomain fabric through our CI/CD pipeline. So this is also a validation use case for what we built in FiveCast. NetOr is tasked with deploying and managing a mesh network connecting all test beds. We have done that throughout the project. We inclusive made several demonstrations in the project that had nodes deployed in different sites. You can see from this picture, very badly, I understand, from the back of the room, but we have sites in Aveiro, Portugal, a site in Murcia, Spain, a site in Bristol, a site in Ljubljana, Slovenia, a site in Patras here in Greece, and a site in Bucharest in Romania. And we were able to connect all of them together and deploy applications. All the applications are feasible to be deployed across this network, interdomain network. So what did we deploy? Well, we had from the onset of the project 11 network applications. Contrary to other projects, and I'm not doing any judgment on that, we started the project with already existing network applications. So our partners are mostly SMEs. They already had some applications. And throughout the project, the goal was to accelerate those applications into network applications with a higher TRL. So to develop the applications towards applications that are 5G aware and benefit from 5G. That meant mostly interaction with the network APIs, the 5G core network APIs, be it the NEF interface or CAPIF interfaces. But the whole point was to accelerate these existing applications to those stages. Also to go through the testing process. So all the applications throughout the project developed tests, not only for their own applications, what we call developer-defined tests, but also develop tests that are cross-cutting between all the applications. That means tests on security, on app performance, tests that can be used by all verticals and all applications. So broad sense tests. FiveCast nonetheless focused on automotive and PPDR. And this can be easily identified from this list of network applications. So we have application on virtual onboard unit, VOVO from Odense. We have virtual roadside unit from Yogoko, a central ITS station from Yogoko, and a multi-domain migration network application also from Odense. We have vehicle to cloud real-time communications from BLB and DriveU, and remote human driving from also BLB and DriveU. So you have just over there half being automotive network applications. But we are not just about automotive applications. So the next applications are actually applications that are cross-domain. We have an application on efficient MAC handover that can be applied to any use case. We have privacy analyzer. We have 5G isolated operations, which is very important application for PPDR. And this is our flagship PDR network application. We have also a vehicle route optimizer that can be used beyond the scope of automotive, but also into PPDR and other use cases. And we have a fire detection and ground assistance using drones by University of Patras. I mentioned the vehicle route optimizer from Neurability, a startup from Romania. Inian provided us with 5G isolated operations, and the privacy analyzer provided by Lambda Networks, and efficient MAC handover provided by University of Bristol. So all these applications have been tested in our test beds, not just in one test bed, but deployed in our fabric, in our interdomain fabric. We have been able to show publicly some of these applications being deployed and validated and experimented with during the past 3 years of the project. And we see that in the future, we can also extend these to other applications. Namely, during the last year, we were able to gather with other projects, namely ICT41 projects, and we were able to deploy their applications into our testbed, but also our applications, namely, for instance, Yorgoco's applications into other testbeds. And we made a strong effort, and I see some partners from these other projects here today that can testify this commitment to integrate across the various testbeds and validate that these technologies that we developed are actually able to be replicated and extended. So this is just to summarize the use cases and the things that we were able to achieve per network application. Well, from these 3 years and all these network applications that are quite different from each other, we were able to learn a lot. Not just to learn and document in our deliverables, but mostly things that we learned that can be brought into next projects, next activities, next products and services for our companies in SME especially. So we have documented all these things that we learned in our deliverables, which are public and available on our website. That means that much, if not all the knowledge that we gathered during the project can and is shared with all the broad community. So in deliverable D44, we provide detailed information on the lessons learned throughout the project, namely the requirements assessment. That was very hard in the beginning when we discussed how we can create this platform and how we can support such disparate use cases such as automotive and PPDR with very specific needs, each of them. So we explored how this requirements assessment was done. We also provide anecdotal reports from users and developers, things that we faced in the day-to-day, things that it's very particular for given applications, but it's experiments and knowledge that we can easily relate to and can be used when we think about new service products or projects for the future. We also create a list of best practices, things that we learned during the development of the project that at the end we include as best practice to proceed in developments, things that we now incorporate not only in our research and commercial work, but also we bring through to standardization. And we can summarize basically these things through do's and don'ts, things that we should do when we're testing and developing network applications, and things that we should not do. I will not get you from the documents, okay? So I will not do any spoiler on what is written there. I call you to go to our website and look at our document, and you have there not very long document, okay? So that it doesn't be to, let's say, doesn't entire you reading the document, and you will be able to get all this important information. At the end of the project, and this is the main takeaway, the TRLs of each of those 11 network applications has reached a higher level. So we consider that we achieved our objective set forward for the project, because all the applications really accelerated, really got to a higher level, really learned a lot. Some of the applications were coming from companies that were not into the telecom business, not aware of what 5G could bring to them. And throughout the project, we could collaborate together, companies and research institutes that work in telecommunications together with these companies from the verticals, especially the automotive vertical, and we could share information, and we could help them bring their applications to a higher TRL that involves communication in 5G. So this was a very important takeaway. As I previously described to you, one of the most important goals was to create a full circle. And it's not just about putting the demo in, showing that the applications work. We also wanted to create a mechanism that showed that the tests worked and that could bring a certification. We do not have any certification entity behind the project. We want to create not a seal, but a summarized information about what each of the network application is about and how high on the TRL scale regarding 5G the application is. So we devised a 5GASP certification process where we run tests for each of the applications that is deployed into our test beds and validates how much of accomplishment in 5G integration each of them has. We have created not a certification in terms of one standard value. No, we created a spider diagram that shows, in summary, the various aspects related to 5G. So we classify each of the applications on the amount of 5G integration it has, security level that it accomplishes, various vectors. We have, this can be read through our deliverables. And this certification spider diagram provides a quick summary for anyone that wants to understand the vendor, the network application vendor, what their application is capable of doing. We think that this process can help the network application developer to approach network operator and quickly establish a common base and understanding of what is their application about and how much of not standardized, but how much of conformance does it provide with technologies. So it provides quick assessment of the 5G features and capabilities provided by a certified network application. And the process is mostly handled automatically. And this is also very important. That means that we have the least amount of human intervention in the process. That means that the network application developer can iterate quickly. So if he's trying to achieve high level of security, he can quickly go through the process several times, all in an automated way, not waiting for an engineer from the other side to go and check and send logs and say that's not working, you need to change that. No, we go through an autonomous process. We have tools that provide the developer with logs, with reports on what's wrong, what can be changed. And this way, the developer of the network application can quickly iterate and achieve maximum success. We have good use case scenarios here. We have, for instance, YogoCode that did a strong effort on achieving high level of certification. And we will not have them today, unfortunately, but we will have eventually future presentations about how they achieve this level of compliance. We also get, as I described before, to extend an existing open source tool, the NEF emulator. The NEF emulator was part of Evolve 5G project. They created the NEF Sim, which serves as a crucial tool for testing advanced 5G network capabilities. When we picked up this open source tool, it was capable of doing simulation of mobility and all the events related to mobility. It exposed the standardized API for the NEF, but we wanted to go a bit further. So we extracted the API out of the NEF simulator, and we created tests that can be used for applications to test against and validate that they can work against the NEF implementation, even though they're not NEF commercial implementations. Developers can already test their applications against a NEF API through the tests that we develop. And we also extended things to go beyond mobility. So we included also QoS. So we made use of the fact that NEFSIM was available as an open source tool, and we have extended to encompass new features. And we believe this is something that will be very useful in the future. And we will have a presentation next, just talking about all these improvements that we made to the NEF emulator. So, and I'm coming to the end of the presentation. What is the main outcomes to take away? The 5GAS project was about creating the CI/CD process, but not only. We also have a very important work package that wanted or wants still to create a community of practice. That means that wants to gather network application developers, people working in this area, not just 5G, now there's 6G, around common place where they can share resources and where they can ask questions and get answers. We created a forum, we created a community portal with documentation, tutorials. There's some motion going on, so we do have some interactions now and then, but this is something that we want to leave beyond the end of the project. So all the portal and all the forums will stay online beyond the end of the project. And we want to make sure that all the open source tools can outlive the project in new forums such as Etsy, but also normally in the open source wide community. We want also to make sure that all the test beds that were created during the project, Aveiro, Bristol, Murcia, Vienna, Patras, Bucharest, can also continue to operate and continue to be useful for researchers, but also SMEs that want to accelerate their developments. We want to also leave, and we have achieving this objective, we want to leave a marketplace, not in the sense of selling it, but at least exposing all the applications that were developed during ICT 41. So basically the marketplace in 5GAS, where you can find our 11 network applications and actually can deploy them in the existing test beds. We have extended this portal to also host applications from other projects, so they can show themselves to the broader community through that common marketplace. And you get information about them, the companies behind them, what can be achieved from each of them. All this information will be very important to document this period of time where ICT 41 projects built very interesting network applications. So this is how we see our project outliving its end. Finally, all these resources, all the stuff that I talked about you today, it's all available online. We made all resources that we developed, except for the network applications that have IPR that belongs to each of the project partners. But all the tests, all the tools that are common have been developed using open source. They're available in our web pages. We have 3 main web pages. So the project web page, which has more the institutional part. We have the community portal where you have the tutorials, information, documentation about the things that we did and develop, and a forum, which is basically just topics with questions and answers provided that are very useful to exchange knowledge. And I think that it should outlive for a long, long time the project. Of course, we have our social networks. Please follow us, and our GitHub repository, where you will be able to find all the things that I talked to you about today. Thank you so much.